All right, so we're going to get started now with some announcements to kick off this week. So first things first is that we have the new assignment. You all saw that come out A01 via a Canvas announcement. So this one will be due on Sunday at 11:59. It's just working on a personal website. And you will also have the chance to deploy it and put it live on the internet so that you're able to access it via a real URL. In addition, there's a new reading that has been posted, reading 3. This will be due on Monday. We're going to just expand on some things teaching about TypeScript along the way. And also the frequency of readings will decrease as we go forward. So I know there's been a lot of readings so far, but that will decrease as we go into future weeks. All right, 2 other things here. And again, I'm still not sure if this mic is actually working. We'll see. Hopefully it's like blinking red and green, so I'll try to speak as loudly as I can here. The CS Open House event hosted by the CS department will be today at 6 p.m. in Sitterson Hall. So please make sure if you're interested in checking this out to do so. And we also have a resume reboot on Wednesday, which is a virtual event. So if you want to get your resume kind of worked on and looked at people in industry, I highly recommend checking it out. All right, so to recap so far, where we've been, right? What have we talked about? Well, the first thing is that we introduced this idea of HTML, that HTML is this language that allows us to provide the structure and the content of our web pages. In addition to HTML, we have CSS, and CSS helps us to provide some styling for our web pages. And so together, we're able to have websites that have content, but also look nice and have a good layout as well. And together, HTML being the fact that that's how you provide your content, and the fact that you can have nested elements, right, creates this hierarchy. And also with CSS, things like the box model, margin, padding, flexbox, etc. All of that together, HTML and CSS is how we provide some layout for our web pages. Are there any questions on this? All right. There's one missing piece, though, that we have not talked about yet. We have content, we have structure, but perhaps the most important part of web pages we have not talked about yet, and that is functionality. But when you go online and you go to most of the web pages that you use, there is some functionality there that website provides to you as a user. It's a very, very foundational part of building our web pages and is the third missing piece along with structure and styling. So how do we actually provide functionality to our web pages? Well, we provide it using a language called JavaScript. So you can see JavaScript here. Is the last piece of the puzzle. We have HTML, we have CSS, and now we have JavaScript. So how does JavaScript work? So how JavaScript typically works is that there's a file, usually with the .js extension that stands for JavaScript, that is sitting alongside your HTML, right? Remember, in the previous lecture, we talked about CSS being a separate file. So we had HTML and CSS together. And then here we have now HTML and JavaScript. And our HTML file can link to a specific JavaScript file using the script tag in the metadata. So you can see here, the only thing that we have added to our HTML, this is the same website that we had last time, but the main thing that we have added here is the script tag. And we write here source src equals app.js. And app.js, which you can see right here, this is the same name of the file over here. So those match up, and this tells our browser that this is the JavaScript file that we are associating with our website. Any questions so far? All right, so let's open this up here. I have a link. You can go to it as well. We're going to open up another StackBlitz so that you can see this in action. So you can go to this link on your computer. If you have the slides open, they should be posted now on the website. You can also click on that link. go.unc.edu/426L03JS. And also write this out so that if I switch from here and you want to access it, you can. So this would be HTTPS, right? Remember our protocol. We need that in our URL, go.unc.edu/426L03 JS. All right. So I'm going to open this up here. There we go. And this is what you should see. So we have this file here called, let me hide this out of the way. So hide controls and close that. There we go. So you can see at the top, I can make this even bigger, that we have this HTML file app.js. And if I were to open up the index.html, we have a script tag that says source app.js. So this should link this JavaScript file to our HTML. And what happens is, and we'll show this, and we'll talk about this a little bit throughout the class as well, but basically when we load this web page, this JavaScript file that is linked is going to run from top to bottom when we load our website. And so a good way to demo this will be to actually go to this website, and I can show you that our JavaScript code that we specified here will actually run. So what I'll do now is, if you're in StackBlitz, you can press this Open Preview and New Tab button, and this will show this page in a new tab on our browser. So I can press this right here. And you may have to press Connect to Project when you do that. And there we go. We now have our website showing up as we had last time, where we have this text. Now, where is this result from our JavaScript actually going to be visible? Well, if we go back, and I think everyone by now has probably completed the TypeScript reading. So you should recognize that this console.log that we write here is essentially equivalent to us printing out something to our console in some other language like Python, right? So in Python, we use print, and then in our console, it shows some output. In Java, you might use system.out.println. There's many other languages. So how do we actually see this console? Well, if you remember from our lecture last time, we opened up the developer tools in our browser, and that allowed us to see the HTML of the web page that we had opened on our screen. And we also got to see the CSS box model in there. But another really core feature, and actually the one you'll probably use the most, is the fact that it shows us the console so that we can verify our output is there. So if you right-click here, now I'm in Safari, but if you're in Chrome, it should be similar. If you right-click, you should see Inspect on the bottom. We're opening developer tools the same way that we did last time, right? So if you do not have this option in Chrome, and I can show real quick in Chrome as well. So if we open up Chrome and we go here, you can click on these three dots, go to More Tools, and then open up Developer Tools. So this will take you to the same place. So if you're in Chrome and you don't have that option in your right-click menu, you can always go to here and click on Developer Tools. All right. So I'm going to do that in my standard browser here. So Inspect Element. And now one option that you should have when I open this up is Console. So you should see this on any browser that you have. I'll demo this on Chrome as well. So if I just went to COM426 25F. And this is our course website, and you press Inspect, there should be a console option. So unfortunately, there looks like to be an error here. But typically, in your developer tools, you should always have this console option, no matter what browser you have. Okay. So if you go back to our website, our basic demo in StackBlitz, and go to console, now sometimes, depending on your browser, you might have this filter that's applied. So if you press Clear Filter, you should now see that in our developer tools, Hello World and Hello 426 printed out to console, right? So if I refresh my page, it should do it again, right? So you can see here, I refresh, and now again, Hello World and Hello 426 were printed to the console. This is visible in our code as well. So we go back to StackBlitz. These are our two console statements. If I were to change this, so let's say I say, instead of hello 426, maybe I say hello, hello everyone, something like that, and I press save. And I go back to my website here. I'm just going to open it up. You'll see in the console that it's now changed to hello everyone, right? So this is equivalent to, again, our console and something like Python. It allows us to be able to print out things as we run our code. Are there any questions here so far? All right, perfect. So in addition to this, of course, as we had before, There we go. We can also show a CSS file along with this. And so we can have an HTML file, a CSS file, and a JavaScript file all for one website. And they're all linked like so. So we have our script tag. Script is what we use to connect to a JavaScript file. And then link is the tag that we use to connect a CSS file. Right? So those are slightly different. You just want to keep in mind that even though for CSS we use link, for JavaScript we end up using the script tag. All right. Any questions here? Perfect. So now what I would like to do is I'd like to show this in the context of kind of the diagram that we maybe started out with in the first lecture between our client and our server. Because this is a really, really important visualization for showing how web pages are actually loaded and how things work kind of as we load web pages on our computer. And so what you'll see here, and we'll have this a lot throughout the lecture because it's a really, or throughout kind of the entire class and many lectures because it is such a useful visualization to keep in mind. So you can see here on the left-hand side, we have our client. That is our computer that has our browser on it. That's the one we're using to load a web page. And then we have some server somewhere. The server's job, remember, it's a computer on our network whose job is to provide resources when we ask for it. And so when our browser, let's say, requests the home page for some website, right? We go to apple.com or we go to COM42625F website. We make a request to a server. I am hiding here the DNS, the DNS part of this, where we would first ask DNS what's the IP address of the server. Then we contact that server. And what we get from the server the first time around on this first request is just an HTML file. So we get the HTML file back. It's called, if we load the home page, is index.html. If we load some other page, like an about page, then it would be about.html, right? So our server will give us an HTML file. And now our client has that. We have that on our computer. It has been downloaded from the internet, from the server. And then finally, two things are going to happen now. The first thing is we're going to start to render this on our screen. So we kick off that process. And second, now that we have the HTML file, our browser will read it from top to bottom. And it will see those two tags, our script tag and our link tag, and say, oh, there is some CSS and there's some JavaScript that I need to load for this website. And so we then make another request behind the scenes for those two things. So our browser first just gets the HTML. That's the first step and the first thing it loads. And then once it gets the HTML, it sees whether or not there's any JavaScript CSS to load. If it sees those tags in the metadata, that's why it's there in the metadata. So it tells our browser we need to load those things. Then we make a request to our server, and we get our CSS and JavaScript. So our CSS is then used for styling our page. And then what will happen next is that our JavaScript code will now run top to bottom. All right? So again, the process here, we load an HTML page first. Then once we get it, we load our CSS and our JavaScript. Like we download that from the server. And then finally, that JavaScript file is going to be run top to bottom in our browser. Any questions here so far? Good? All right. So a question you may have been thinking of is like, OK, well, so there's JavaScript. That is the language that you're saying provides functionality to our web pages. But over last week, we were assigned a reading on something else called TypeScript, right? So you're probably wondering what the difference between these two things is. And we're going to be talking about that this lecture because TypeScript is ultimately the programming language we're going to use in this class. And so it's important to understand how TypeScript and JavaScript relate. So in the last reading, you learned about TypeScript. And all TypeScript is what we call a superset. So if you imagine JavaScript as a language right here, these are the base JavaScript functionalities. TypeScript is what we call a superset. It's like a wrapper around JavaScript that provides extra functionality. So at its core, it's still JavaScript. It's just JavaScript extended with a few extra nice features, right? So that is the relationship here. We have TypeScript. And we have JavaScript. JavaScript is what TypeScript is based off of. And all TypeScript is it just adds a few extra features to TypeScript that makes it easier for us to use as developers. right? Provides many features that makes it easier for developers. What are these features, right? So specifically, one of the key pieces that TypeScript provides over JavaScript is that TypeScript is what we call statically typed, rather than JavaScript, which is what we call dynamically typed. So what is the difference here? Well, with dynamic typing, variables, any variable in your language, the data type of a variable is determined at runtime. So when the program starts running in our browser is when we end up assigning values to variables, and then those variables get data types. What this also implies then is that at any point in our program, we can assign different types of values to the same variable at any point, right? So even though we may assign a value to a string, as that's our first assignment. Let's say we create a variable called a, and we say a equals hello world. That's our first assignment. Well, later on, we can say a equals 4, and that is valid because the language is dynamically typed. The type of that variable is determined as we are running our program and as we're going through, rather than before when we actually compile our program. So that's the difference here. Static typing is that our variable's data type is determined all the way when we compile our program initially. So before it ever even runs, when we compile it, we determine what types our variables are. And so you have maybe seen this idea of compiling before in some classes like Comp 211 and Comp 301. And so there's no expectation here that you know exactly kind of why static typing is better, but I would like you to start thinking about it. So over the next 3 minutes or so, try talking with the people around you. Why would a language with static typing be better or easier to work with than a language with dynamic typing? So spend 3 minutes on this, and then we'll come back together and discuss. All right, everyone, we can begin to come back together here. Sorry, again, my mic is not really, I'll try and get this fixed by next lecture, and hopefully then it'll be easier to hear me. So does anyone have any thoughts as to why static typing might be better for us compared to dynamic typing? Any volunteers? Yeah. Mm-hmm.
Instead of having to determine the types every single time you come across a variable, you just determine it once when it's compatible and like put it done with that.
Yeah, that's a great thought. In fact, that is true. So there are some cases where certain variables can be allotted to more space than others, and so knowing the type beforehand will help with that. So that's perfect. Any other thoughts? Yeah. Mm-hmm.
With JavaScript really opens you up to a lot of runtime errors.
Mm-hmm.
Like if I have something like a function I want to do on a string, but that somehow ends up with int, then
Yeah.
I'm just going to get a runtime error.
Exactly. That is very well put. So you can imagine that if you know, in a dynamically typed language, if the type of your variables can change dynamically, and there's not ever a guarantee in your program that the type that you're expecting to be in a variable is actually the type that's going to end up there. And so that can cause a lot of issues, as you were saying, during runtime, where maybe you're expecting a variable to be a string, and you try to run some sort of string operation on it, but it turns out that the value that was put there somehow ended up being a number. Well, your program is not going to catch that for you before you run it, because it doesn't know what that variable's type is going to be until the moment that it's running. However, if you are statically typed, then anytime a number is we try to assign a number to that variable, it's going to say you can't do that, it's not allowed before you even run it. It's at a compile time. When you try to compile the program, it says there's an error here. And so that is perfect. So yes, there's some benefits, especially with efficiency, and also more so the errors that you end up getting can be a headache to deal with if you're working in a dynamically typed language. And I want to show some examples of this and the differences to kind of really help to make this more concrete. So again, here you can say it's kind of says here we can catch errors early before runtime. Here is an example of two equivalent programs, one in JavaScript with dynamic typing and one in TypeScript with static typing. So one thing with TypeScript is, again, because it's statically typed, we have to essentially declare the types of our variables. Either that is done explicitly, like so, where we have number, number, and number, or it can be done implicitly in certain cases. But when we're writing our program and when we go and compile it, our compiler knows that this is the type of the variable. So if we ever try to assign something to that variable where the types don't match, it's going to give us an error. In JavaScript, that does not exist. So you can see both pieces of code here should be doing the same thing. In theory, I'm trying to write a program that just adds two numbers together, or create a function that adds two numbers together. On the left-hand side, you'll see, and as well as on the right-hand side, if I just run add with 2 and 3, that is fine. That's what we want. However, what if we instead use add and then put strings 2 and 3 in there? So in JavaScript, it's going to allow this because there is no type checking beforehand. And we'll end up, instead of giving an error saying you're not allowed to do that, it's going to actually try and continue on assuming that everything is fine, and it ends up concatenating two strings rather than giving us an error. But in TypeScript, it will say, hey, the way you wrote this program, that's not allowed. You put in a string where there's supposed to be a number. We're going to give an error there when you even try to run it. So there's it's not like you're running your code and you can get some wild, unexpected result. It will just tell you you're not allowed to do that and make you fix it at that time. All right? Another example to add on to this is with with objects. So you can see here in both cases, I've created this user object with two fields, one name and one age. So in JavaScript, I've created a user named Ramses, age 28. Same thing with TypeScript. However, if I try to access a field called address on this object, in TypeScript, it's going to give an error because it knows that the type of this object, when we assign it, is been given to an object with two fields, name and age. And if we try to access a field that's not part of that type, we're going to get an error. It's going to tell us, hey, you can't do that. Address doesn't exist. But in JavaScript, it's going to keep going. And instead of giving you an error, it's just going to say that value is undefined. And it will continue running. So you can imagine that if you have some operation after the fact with addresses, where maybe you are formatting the address, you're doing something on the right with TypeScript, it's just going to error out immediately. However, on the left, it's going to continue to run, and you can get really unexpected results because an address is not even part of that object. It also makes it much harder to debug. Because let's say you wrote this code and you expected an address field to be there. Well, on the right, TypeScript's going to tell you that you're trying to access a value that doesn't exist. In JavaScript, though, it doesn't give you an error. It just keeps running. And so then you have to manually look through your code and try and figure out what went wrong here. Why is this value undefined? And so you end up with a much better development experience with TypeScript than JavaScript. Are there any questions here so far? All right. So there was a study, I believe it was done by Microsoft. It may have been done by somebody else. I do not entirely remember, but I want to say it was Microsoft that basically did some analysis and found that just using TypeScript, so just instead of using JavaScript, you write the same program in TypeScript, that helps to solve nearly 20% of all of the errors that you would have had if you had just been developing in JavaScript. So because JavaScript, the biggest problem with it is, again, you have these runtime errors and type errors that you don't really have any idea of what they really are. And so imagine if you could make one simple change to your code and you end up solving a fifth of all errors that you get. That is a really, really big improvement, right? And so that is one of the biggest reasons as to why TypeScript is preferred in industry rather than something like JavaScript. And also, it is great for us as in the classroom setting, because if you imagine you're learning a new programming language and you're trying to debug your code and you have these weird type errors, it's much harder to debug. It's a lot more frustrating, and it will cause a lot more problems. But if you have something like TypeScript, then it will help you along the way and tell you that, hey, there's an error here because maybe you're accessing a type that doesn't exist, you're assigning a variable incorrectly, et cetera. Right? So a language also, I'll give a bit of, on top of this, a language like Java that you used maybe in 301, that's also statically typed. Because if you get an error or you compile your JavaScript code, it will give you the same error. You can't just say like int x equals 5 and then the next line write x equals like true or something like that. You can't do that in Java. It's the same idea. And so therefore, in COM 426, we're going to use TypeScript instead of JavaScript. But don't worry, in the sense that if you ever have to use JavaScript, it's essentially syntactically the same. The only difference here is just the fact that with JavaScript, we do not specify types. So as you're learning TypeScript, if you ever have to use JavaScript, you should already pretty much know JavaScript. You just have to remove your types, and it should be nearly the same. Any questions here? Amazing. And to back this up even more, there's a pretty cool survey from 2024. I tried looking today. They haven't updated yet for 2025. Hopefully it comes soon. As to, this is called the I believe, State of JavaScript, State of JS. It's a pretty cool survey. And they survey developers in like a community. So like the JavaScript community, there's a survey and it asks, how many people are using JavaScript over something like, TypeScript over JavaScript. And you can see here that if you look at this graph from 0% TypeScript to 100% TypeScript in terms of the amount of balance between JS and TypeScript they're using, you'll see that nearly 2/3 of JavaScript developers, according to who they surveyed, said that they write more TypeScript than they do JavaScript. And you can see that a lot of programs are being written more in TypeScript rather than JavaScript as we continue on. So TypeScript is something that is used very, very heavily in industry because if you're a company, of course, you want to make sure that your developers are spending more time creating and developing, less time debugging things like type errors. All right? Any questions with that? All right. There's a problem here, though, as there always is in the world of software engineering. The problem, though, here ultimately and unfortunately is that the browser only understands JavaScript. So your browser can only run JavaScript code. It cannot run TypeScript code by default. So that means that even though we're writing in TypeScript, by the time our browser is running it, it needs to be JavaScript because a browser can only run JavaScript code. It cannot run TypeScript. So JavaScript is an interpreted language. It is run from top to bottom, right? So instead, what we have is that TypeScript code needs to be compiled or translated. The term they use in the documentation is transpiled. I guess it's like the combination of translated and compiled together. TypeScript code has to be transpiled into JavaScript code so that the browser can understand it. So even though we write in TypeScript, ultimately we need to convert that TypeScript to JavaScript so that our browser can run the code that we write. And so this step, this translation or a translation step occurs when we, what we call build our project. And all that building means, when we say build our project, building just refers to getting our project ready to be deployed. And by deployed, we mean putting our code on a server so that the server can start handing it out to browsers that want it or request it. Questions so far? I'm going to show a visual for this as well. Yeah. Great question. So what'll happen here during the translation step? The tool that we use to compile our TypeScript or translate our TypeScript or JavaScript will check for all the types being correct first. So when if there's an error with our types, before any JavaScript code is produced, TypeScript will check that for you. So it is at this step when we build our project that it will say that either you're good to go, all your types match, and we can translate it now, or there is a type mismatch, and we're not going to translate it. You have to fix it before we continue on. Does that make sense? Perfect. Any other questions? Yeah. Yeah.
Something that doesn't exist in JavaScript. Like, yeah, okay, that's it.
Yeah, good question. So I think what the question is here is like, if types exist in TypeScript, then how can, like when we write our JavaScript, how does it translate over? Perfect. So the type annotations that we write in TypeScript is just for the TypeScript compiler to check that all the types are matching up. So what'll happen is we write some TypeScript code, and actually I'll show that here. So let me jump a little bit ahead. So we said TypeScript cannot be run. So what happens is we have this setup here where we have our code that we're writing, let's say in VS Code or something. We're writing our TypeScript code. Ultimately, though, on the server, we want to produce some JavaScript code, right? So TypeScript itself is responsible for this conversion. There's a TypeScript compiler. I think it's called like TC, something like that. It's the TypeScript compiler. It's going to read through your program, and it's going to see that we gave all these type annotations, we inferred the types of variables. Do we have, are there any problems? Like, do we assign some value to a variable where the types don't match? Do we try to access something that doesn't exist, et cetera? If it does, we're going to get an error in that step. So your code will, it'll give you an error saying that there's a type error here, you need to fix it before it's ever translated to JavaScript. Once it confirms that all of the types and everything are good, it can essentially remove all the type annotations because it's already confirmed that everything's good. I've already checked it. We can now remove all of it. So what's left is just pure JavaScript. So even though we have type annotations, like if we go back here, let's say something like this. I think this one's good. So even though we have type annotations here with number, 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 our TypeScript compiler will check and see, are there any errors in this code? If there are no errors, then it can translate something like this into something like this because those type annotations are only for that step of checking that all of our types are correct. Does that kind of help? Okay, perfect. So again, the idea here is the result of our compilation, this conversion from TypeScript to JavaScript, is JavaScript code. And the type annotations that we provide in TypeScript are removed by the time we get to our final JavaScript code, right? The only reason why this is here, these type annotations, is so that during that conversion process, we can check and make sure, is our code what they call type safe? Is everything, are we behaving as though our variables are typed? Are we assigning the right types to variables? Are we accessing the right values, et cetera? Yeah. Mm-hmm.
We're getting a JS file.
Exactly. You're getting a JavaScript file. And we'll see this. So you'll get a JavaScript file because that is what your browser can understand. We write it in TypeScript, but ultimately, before we put our code on a server so that someone can access it, it has to be converted to JavaScript. Yeah. So the main point is that step. So because we write in TypeScript, the type checking that TypeScript does is only possible if we write in TypeScript, right? So if we write in TypeScript, we can supply type annotations because in JavaScript, type annotations are not a thing. Yep. Because if we wrote in pure JavaScript, like something like this, then we cannot provide, we cannot check beforehand whether or not we kind of manage our types correctly. So if if we wrote just this code on this side and we were to have this add function with passing in a string 2 and a string 3, there is no step that we have to know that is problematic because we don't have the type annotations. Yeah. Yeah.
If TypeScript is already compiled down in Java,
yeah.
why wouldn't we always try TypeScript? Why would a company ever bother writing JavaScript?
Oh, the other, okay, got you. So sorry, I think I interpreted the other way. So yeah, why would we always write in type, or why not? Well, TypeScript, first of all, is newer. So that's the first thing. JavaScript was first. So there's a lot of code that was written in JavaScript first, and then TypeScript came along, and so then you can either convert your existing code into TypeScript, which takes time, and so some companies don't want to invest in that. They might just want to write new code in TypeScript, or maybe they're using specific tools that were built only for JavaScript. and they're not compatible. Those would be kind of the two main reasons. Otherwise, most companies these days would prefer to write in TypeScript, and most open source projects are as well. Yeah.
So maybe besides the load time and the time they're actually.
Yeah.
Any like notable efficiency by TypeScript instead of JavaScript?
Good question. I do not think so, because ultimately, like, the build step only happens once. Well, when I say once, it's like the user doesn't have to go, like the user, when they load that code, it's already has been translated. So it's not like every time a user is accessing the code, it has to go through that process. So it only happens once when we put our TypeScript code onto a server. So it would be negligible at that point, because then the code that you have afterwards is just JavaScript code. Perfect. Yeah. Sorry?
JavaScript dynamic, so that would be the runtime error,
Yes, exactly. Yeah. Well, actually, so this in this case will, that's a good question. So it will work because it's not going to give a runtime. Well, actually, yes. If you're saying that at runtime we're expecting this code to like, I guess the way we define runtime error is like when something happens, our program doesn't necessarily crash. It's just something happens that's not what we expected to happen. So in that case, yeah, then a runtime error would happen. But with TypeScript, it would error out when we try to run it to begin with. Yeah, so that's I may not, I will commit to it and go as far as to say yes, TypeScript is better for these reasons. There's really no drawback to using it, because you're getting the type safety, which is the main feature of it. You're not really losing anything by going with TypeScript. So it is better, but there are some companies and some projects that may still use the old, like, use JavaScript. It's not inherently, if it's working and they wrote the code at that time and it's working, then it's good. But TypeScript typically, especially if you're working on your own projects, it's invaluable because it helps to solve a lot of those type errors. Yeah, good question. Any other questions? All right, amazing. Great questions, by the way. So keep it up. I appreciate it. So yeah, we'll go back to this diagram here. So again, we said that our TypeScript code cannot run in our browser. And so ultimately, what happens is we need to translate it, right, to JavaScript. And this happens during the build step. So when we say that we're building our project, that is getting our project ready to be put onto a server. So maybe we've developed a new feature, we've added a new page or website, and we say we want the world to have access to it. So we're going to take our code and we put it on a server so that when somebody goes and tries to load the website, it will download that code. Well, when we do this, TypeScript is going to be transpiled into JavaScript code. So it's going to go through that conversion step. And we're going to see exactly what runs this step in a second. All right, all good? Perfect. And so then ultimately, even though we develop in TypeScript, what the user receives, or like what the client receives ultimately, will be JavaScript so that it can run properly in the browser. All right, so now there is a attendance check. So we have a short discussion. We want to try and connect this back to other courses, because you've actually seen this process before many different times in a class like 211 and 301. So I'd like you to think back and say, were there any processes or any tools that we used that converted code that we wrote into another format so that it could be run? So spend 3 minutes on this. You're welcome to work in groups, and on Gradescope for the attendance check, there is a ability, I think, to add teammates, so you can add more people to your submission if you like. And so we'll talk about this for 3 minutes, then we'll come back together and discuss. All right, everyone, we can come back together here. I apologize again, my mic is still not working, so. All right, everyone, let's come back together. I apologize for shouting again. My mic is not working, so it's very hard for me to kind of get everyone back together. So apologies for that. So as some people mentioned in the beginning, the ability to submit for groups was not available. It should be now. So if you want, you can go back to your submission. There should be at the top right, should say like edit group. You can add people in there, or you can write in the text box you worked with somebody, and I'll fix it behind, like, after the fact. So totally fine. Apologies for that. But yeah, did anyone have any thoughts on this? Maybe from something from 211, 301, where you had a similar conversion of code from one format to another? I definitely heard the right answer in a lot of places. So I know that people have the right idea, but any? Yeah.
So, I mean, yeah, it wasn't C code was simply C code.
Exactly, yes. So in 211, C code, right? We could write in C, but our computer does not understand C code. It only understands like assembly or machine code, and so we had to convert C code over into that format in order for it to run. That's perfect. Anyone remember from 301? I know 301 might be harder to remember because it was kind of built. It was an automated process when you press the run button. Yeah, all the way back there. Exactly, yes. So Java code also could not be run on its own. It had to be converted into what we call Java bytecode, or a .class file, and that was run ultimately on our computer. So you've seen this before, and sometimes you take it for granted. We press the run button in IntelliJ. IntelliJ just does all of it, but behind the scenes, there is that process there. So again, to kind of round this out, so in Comp 211, C code was converted into an executable using something like GCC. That's the C compiler. In Java, you use something like Maven or Gradle, and your Java code, that was the build step. Your Java project was then converted into bytecode with a .class file extension, and that ultimately ran on the JVM, the Java Virtual Machine. And that's why Java can be run on any sort of devices, because the JVM is kind of that, is the tool that runs your Java code, but only it understands these class files. And then finally, in this class, we have a similar situation where our TypeScript code needs to be built so that it is converted from TypeScript into JavaScript so that it can be run in the browser, right? So there's a question mark here because we have not talked about the tool that actually does this. We've just talked about the process. And so now I'm going to introduce this tool, which some of you, if you've been seeing kind of stuff related to TypeScript or JavaScript online, you may have seen this come up before, which is called Vite. So it's spelled like Vite. It's pronounced Vite. I believe it's because, I might be wrong, I'm pretty sure that it is going off of a French pronunciation from, if I remember what the documentation said. If I'm wrong, I apologize. So there are many tools out there that allow us to build our TypeScript code. And part of this build step is this transpilation, this conversion from TypeScript to JavaScript. Vite is one of those tools that allow us to do that. And it's really, really good. It's very fast, very optimized. It converts, it runs all these steps very, very quickly and does a very good job. And so StackBlitz, the tool we've been using, uses Vite by default. And I'm going to show you an example of this working. And another great thing about Vite is that it essentially allows us to simulate a server locally on our computer. This is how we're able to ultimately interact with and load our web page, because typically, right, we take our TypeScript code, we convert it to JavaScript code, and it's put on some external server, and then we use that URL, except as you're developing locally, you want to be able to access your website. And so it'll basically simulate some server on your computer that then you can access, so you don't need to put it on a real server in order to test your code. Now, Vite is an example of an external package. You can use it. There's many packages that you've used in different programming languages. Vite is one of those. Any questions so far? Yeah. Yeah.
They all use
Great question. So yes, TypeScript has its own compiler. There's one compiler that's released as part of TypeScript, and that is bundled in. So Vite runs the TypeScript compiler. So the TypeScript compiler is its own thing, but Vite runs it as we build the project. Yeah. All right. So I think this leads us very well into a short introduction into environments, because we're talking about Vite. Vite is a tool that we need to run, and so we need a place to run this tool ultimately. And so Vite itself, as a program, is written in TypeScript and JavaScript, right? So we have heard this idea throughout this lecture that JavaScript has to be run in a browser, right? JavaScript is run by your browser. However, there are many cases where we want to run JavaScript outside of a browser. We want to just run it as if it is a program on our computer. We don't want to have to go to a browser, load in some JavaScript, and then use our console to actually interact with it. All right, so typically JS is run from a browser. There's a problem with this, though, is that our browsers, if we're just running JavaScript from our browser, it doesn't have direct access to things like our files or access to our terminal or access to the shell, right? Because it's contained within the browser. And the projects that we're developing, and we're writing Java, we're writing HTML, we're writing CSS, we're writing TypeScript, that's all on our computer, maybe in VS Code or something like that. And so if Vite is itself a tool written in TypeScript, we want to be able to run that from just outside of the browser, just on our computer. Right, so again, here it says, if we want to use a tool like Vite, we need to then be able to run JavaScript outside of the browser environment, so that Vite can see our project code and be able to interact with our terminal and our computer to perform these conversions. And so there's a very, very powerful tool, which we'll be using throughout this class, called Node.js. Node.js, all it is it's just an environment on our computer that allows us to run JavaScript code separate from a browser. Right, so all it is, we have our Node environment. You can think of it like this box. And we can put our JS code in there, and we can run it. And it's just going to run like a standalone program. You don't need a browser to actually have this run. And all an environment is it's just a space on your computer where code can run. And we can load in maybe some external tools, like external packages or something like that, that our code can then depend on. You've done this in a class like Comp 110 with Python, and we'll see that as an example where you use like Python packages because your Python code is running in a local Python environment. So I'm going to show that in a moment. Right? So you can see here that JavaScript code, maybe we have other people's packages that we want to run. We can import those packages into our program and use them just like any other programming language. And so ultimately, then our code depends on those packages existing in our local environment in some way. Any questions here so far? Perfect. And again, when we say environment, the Node environment is just it's running on our computer. So it's part of our computer. You can even think of your computer itself like an environment. There's a lot of different things running on your computer, different standard programs, like, for example, anything you run in your shell, right? That is something sitting in your local environment. And so Node is part of this. And we can install external packages into our environment using a package manager like npm. So if we want to use the code that someone else wrote in our program, we can put this code that someone else wrote into our environment using a package manager like npm. And we do that using a command like npm install. So you'd run npm install, then the name of some package, and then it will install that. It'll basically take all the code that person wrote and put it in the environment so that we can access it. Vite is an example. So we could install Vite into our environment. And there's many other examples that we'll be talking about later on in the course. I want to relate this, though, back to something that you've already seen. And so I want you to recall this from Comp 110, which is that when we used Python in a class like Comp 110, you use something like pip install to install packages for your Python programs to use. And this is a very similar idea. On your computer, when you install Python, it creates a Python environment, and then we can install external packages using pip install. So pip install, in your Python world, that is a package manager. And we installed a bunch of packages into your Python environment so that when you run your Python code on your computer, it's able to import these and use them. And I'm not entirely sure if 110 uses, maybe in the past it did like pandas or something. Did it use, there's some packages I know that, I know Comp 116 probably does. Comp 110, I know that there are some examples where you may have used external packages in 110. I don't remember exactly what they're called off the top of my head, but you have seen this and you've used this before, even if you have not really been aware of what's actually going on, right? So there are various things in the Python world that are directly translatable here. And as you learn more programming languages, as you learn more technologies, you'll begin to build these connections between all these different things, right? So like GCC and Maven with Vite, right? As these build tools, our Python environment to our Node environment, pip and npm, all of these things they serve a similar purpose, just for different programming languages. Are there any questions here? Amazing. So to kind of put everything together here, I have this URL, which you can also go to. And this is going to give us a StackBlitz project that has a TypeScript file in it. And so you're going to see how all of this ends up coming together in StackBlitz. So let me find my mouse here. So there we go. OK, so let me hide this bar. And let me open up this URL. And you'll see, and again, you should have access to this because you have the slides. But again, go.unc.edu/426-L03-Vite. Good. So when you go to this URL, you will see this should happen when you open it. We get an alert that says, hello from TypeScript. That's the first thing that appears when this web page appears on the right side of StackBlitz. And the code that is ultimately running here is this window.alert. So you can see window.alert, that pops up an alert on our browser, hello from TypeScript. And this TypeScript code is running within, like, we have our TypeScript code, and ultimately Vite is, and throughout the build process, this TypeScript code is converted to JavaScript so that it can run in our browser. And you can see down here in our terminal that Vite is listed here. And typically, the way that this works in StackBlitz, you can see there's like this little purple kind of chevron here that shows the commands that are being run inside of our in our local terminal here to get everything running. So you can see the first thing that happens, we do run npm install. So we're installing all of the packages or all the external tools that we list. There's a separate file in our project called package.json. So if I go over here, and you'll see there's this file right here called package.json. And when I open it, all it does is it provides under dev dependencies here, sometimes just called dependencies, all of the different tools or different packages that we need in our environment in order for our code to run. And so we have TypeScript, and we have Vite. Those are the two things we're installing. And so when we run npm in our terminal, it is installing these two things into our environment right here in npm install. And then the next thing it does is it runs this script. It says npm run dev. And the script that's ultimately running, if you look in package.json, we have this list of scripts. And dev corresponds to Vite. So when we run npm run dev, we're telling Vite to build our project and to start up our local kind of simulated server that we can then access. You can see that down here. So in our terminal, we run this, and then it says added packages. So we installed everything we needed, and then Vite runs. It says Vite, this is our version, and then it gives us this local address, a URL that gives us the ability to load this web page on our in our browser. So you could go to this, and if you're running this locally in VS Code, you can copy paste this exact URL in, and you'll see that then it takes us to the home page of our site. All right. Any questions here so far? All right. So lastly, we go back here. I want to kind of expand just slightly on this npm run dev step and this idea of this development server, this fake server that's running. Again, remember that in our original diagram, right, and I'll kind of draw this out here. In our original diagram, we have we have our client. So let me, there we go. We have our client here. And our client requests files from a server. So we have a server here. Whoops. There we go. Server. On the server is our files that we need. So we have HTML, we have our JavaScript file, and we have our CSS file. And our client makes a request to the server. We get our HTML back, and then we ultimately get our CSS and JavaScript to load, right? This is assuming that there is some server somewhere on the internet where all of these files exist. But when we're just developing these projects on our own, we don't have a server. And so we still want to simulate this process. And so instead what happens, instead of having a separate client and then somewhere else on the network we have a server, what Vite will do is it's going to essentially, and I'm going to clear this here and write this out. So you can imagine this is our client. And then maybe we have a browser here. So this is our browser, draw browser. What Vite will do is it's going to create a simulated server, a fake development server, locally on our computer. So this is simulating a server that's somewhere else on the network, right? Except it's actually on our computer because we don't own a server. So the entire idea is that we're just simulating it. So it's as if we are accessing a web page from some other, somewhere on the internet. But in reality, we're just accessing it from within our own computer. So this is our development server. So this is what we call a dev server or a simulated server, anything like that. It's going to put our files here, our HTML, JavaScript, and CSS. And so then our browser can access it using that domain, something like localhost, and then some numbers after that. And that is the essentially URL to access this server sitting on our computer, this fake development server. Are there any questions with that? So in summary, I know there's a lot today, and so I want to provide a bit of a summary here of what we talked about. So first off, again, in 4.26, we will use TypeScript to add functionality to our web pages. Everyone, we still have 2 to 3 minutes. Who can hold for a second, please? Thank you. So TypeScript adds functionality to our web page. Our browsers only recognize JavaScript, so we need to convert our TypeScript code to JavaScript. And of course, this is worth the effort because TypeScript is statically typed. And Vite is the build tool that will help us do that conversion for us. And to make this happen, we need to put our code in a node environment that we can run Vite on our computer because it itself is written in TypeScript. And finally, we can run npm run dev, which will allow us to essentially interact with our web page as if it was on some external server. So it's just simulating the server. HTML, JavaScript, CSS are all sitting on that fake server, and we can access it using that domain. All right, so next time, I don't think there is any remaining time, so you can continue working on A01. Office hours started on Monday, so if you have any questions, feel free to ask there, and we'll see you all on Thursday.